Good morning. Welcome to the premium public video forecast discussion for Friday, September 6th, 2024. Of course, I'm your meteorologist, Stephen DiMartino. And as we do most of the time at the end of the week, we have a little bit of a premium preview of what we do every day in the premium section. So let's dive into some very interesting data. Now, first of all, this is the solar cycle, the sunspot activity. And as you can see, for the month of August, we got up to 215.5 sunspots this last month, which was well above the predicted value. Down here's the predicted value. So bit of a bust in that respect. It really shot up very impressively. The reason why I find this very interesting and something that I normally don't show in the videos, but I do talk about this every week, usually on Thursday evenings, about the progression of the sun. The solar cycle does have a somewhat of an impact, especially on the stratospheric nature of the atmosphere and the potential for high latitude blocking. And so during our seasons where we had the most robust high latitude blocking, that's when we also had very low sunspot activity. As you can see, we have been moving to well above normal. What we're moving towards is the maximum, solar maximum, and it looks like we may have just peaked. Now, in previous years, in previous cycles, when we've seen this peak, and we can zoom out here a little bit and go back to, let's say, the last major one, which was in the early 2000s back here, we saw a peak of around 180. So still, far more impressive, but still pretty impressive stuff here at 244 in July 2000. And in October 2001, you saw a peak of 194. So I think what I'm trying to show here is that it looks like we're nearing the peak of our solar cycle, which we should start to see a decline in 2025. And so as we head towards the 2030s, we'll start to see less and less development of sunspots. And with a blank sun, you allowed the ability for ozone to build up and some interesting weather patterns over time. This isn't a one-to-one ratio. This is a great example of how atmospheric conditions evolve. There's a lag time, but you can start to see some of the connections between the activity in the sun, the activity on Earth. Again, this isn't where a one-to-one ratio where you get a sunspot and therefore the weather changes. So I know a lot of people, they like to, on social media, like to show, hey, look, sunspot activity, therefore storm. It doesn't work like that. This is more of a long game, okay? This is like, in terms of sports, right? If you draft well, say you're the Kansas City Chiefs, for example, and you draft a quarterback, that doesn't mean the next season you go to the Super Bowl. It means that you set yourself up, because you got a Hall of Fame quarterback, to go to several Super Bowls, right? Well, in this case, the sunspot peak here doesn't mean we won't see any high latitude blocking, but it certainly reduces the chance. It sets up that reduction of more of a positive North Atlantic oscillation, positive Arctic oscillation. However, as we move towards the solar minimum in the late 2020s and 2030s, you increase the potential for more activity. And by the way, this forecast here, where it's very low, I would probably discount this part here. This looks like a bit of an error, unless we go into some sort of grand solar minimum, which has been talked about, but I have my doubts on that, but we'll see how that plays out. But certainly interesting. I just wanted to show, hey, here's what happens with the sun. And this is why we monitor these things, because it kind of tells us the long story of what is evolving in our planet. Meanwhile, a little bit closer to home, in the stratosphere itself, we are in a westerly QBO phase. Why is that important? Keep an eye on this term when the seasonal forecasts come out, the winter forecast and all that stuff. If people aren't pointing this out and just making vague terms or just pulling out model guidance saying, oh, look, blocking, or oh, look, no blocking, you're not getting the full story. One of the primary factors here of the evolving weather pattern is the state of the QBO and how that interacts. And basically, when the QBO is easterly or negative, The stratospheric winds are going against the polar jet stream evolution and leads to a weaker polar vortex. When it's going positive, it's going along with it, so it enhances the polar vortex, leads to the potential of a stronger polar vortex. Doesn't always mean that the polar vortex can't be disrupted. It's a heck of a lot harder. So interesting setup here. Usually sets up more of a progressive weather pattern in the cold season months, which we are now in, as we are in fall. Meanwhile, our La Nina is finally starting to gain some ground. We're not there yet. Okay, this is going to take some time for it to actually establish itself, but clearly we are seeing a shift towards more of a La Nina state. The weather pattern itself is not feeling the full influence yet. We do have, statistically speaking, a negative PDO setup here, but we're missing a lot of the cooler waters over the Gulf of Alaska. We'll see whether or not this starts to shift a little bit colder, but this is statistically a negative PDO pattern, and in terms of the thermal gradient, would support a negative PDO pattern. So you have a negative PDO in place, which typically leaves a trough right around here in the fall months. Right now, we have a trough in the east, but I think as this starts to get more established in the Gulf of Alaska, we're going to see a more of a trough in the Pacific Northwest and a broader ridge or zonal pattern over the eastern United States, and more of Pacific air masses rather than Canadian air masses coming in. La Nina influence not in the cards just yet for at least the first half of this fall. Second half, I like that idea, like mid-October on. And of course, this is one of the factors why our tropical Atlantic season, although we have plenty of warm water, has produced less than expected activity. That is for sure. Now, one of the ways to study whether or not we're seeing an atmospheric change is the SOI, the Southern Oscillation Index. I am a big believer, more than adjusting statistics to global warming or anything of that nature, to study this factor. Why have we not seen much in the way of tropical activity? Well, our atmosphere is acting more like the El Nino than La Nina for much of the summer, which means you have more vertical wind shear over the tropics, not much activity. And the intertropical convergence zone has been displaced. The short waves coming off haven't been able to maximize and utilize the very warm Atlantic waters because you're dealing with more Sahara dust. But now we're seeing that shift. So we should see a little bit more activity in the tropical Atlantic. I mean, we are near the peak. So this would suggest that we're going to be trending more towards La Nina conditions, but again, there's a lag time in this. So the way to use this data here, just so you understand, these are the daily values, these bar graphs, and when the bar graphs are positive, you typically end up with less convection around the date line and more of a quiet weather pattern for the eastern United States. When they're negative, like back here in August, you end up with a little bit more of an active weather pattern over the eastern United States in the cold season months, especially in the winter. Higher potential for East Coast cyclogenesis and winter storms. Meanwhile, this red line is your monthly value, so you can see the trend, and then this dash line is your seasonal value. This is what I look for in terms of atmospheric impacts on the overall weather pattern. And right now we're in a neutral state. We got some time before we get into a positive state, which would support a La Nina atmospheric environment. But right now, as you can see, we've been in this weak neutral negative phase. So as a result, you end up with more of a El Nino feel, but that is starting to dissipate. So that is why we're seeing that gradual change. And of course, all of this in terms of the weather pattern evolution is, in my opinion, is influenced by the evolution of the Eastern Pacific Oscillation, which is basically that trough around the Gulf of Alaska. And as you can see, as it's wavering and gradually trending toward the negative state, you're going to see wavering periods of active weather and quiet weather over the eastern United States. As you can see here, we've been rather quiet as we moved into September. It looks like with a positive state, that is going to be a theme moving forward. So if you don't like storms and you like your falls to be a bit warm, Well, we got some good news here with this positive state showing up here. Because what that means as the pattern evolves, that you get more of a trough around the west coast of the United States. You can still get a trough, especially in your subtropical jet stream on the east coast. So this is going to protect you from a lot of tropical systems. But what this typically does in terms of our air mass sourcing is that it sources it from the Pacific rather than northern Canada. So right now we have a general cool weather pattern, but as we move on through the forecast period, we'll shift more to a Pacific pattern, which is slightly above normal, nothing that is well above normal. We're talking about 70s and 80s rather than 60s and 70s. So that's essentially what we're dealing with here as we move forward through into the middle of September. So certainly some good news if you like comfortable weather conditions. I don't see anything that is excessively cool or excessively warm in this weather pattern. And again, with the persistence of a trough axis here on the East Coast, that typically protects you from the East Coast from any tropical systems. But the Gulf Coast, you still got some concerns there that you have to keep an eye on. Of course, you actually have to have something developed to actually be worried about it. As you can see here, not much. If you look at this generally and not look at the NHC website, you would say, okay, nothing's really going on. NHC has highlighted a couple of areas. This area right here has been highlighted for about 2 weeks, actually going back here to 2 weeks, as expected development. It has not developed. It's moving into the Yucatan Peninsula. It has about a 20% chance of developing in the Gulf of Mexico. I think that's based mostly on model guidance to actual any observations, because look, there's just nothing developing. It's just a trough, no low level circulation, nothing. Along the Gulf Coast here, we have active heavy rainfall around Louisiana with a trough and low pressure system, but this is all getting drawn into the subtropical jet stream. So again, maybe a 10% chance of developing, not really all that impressive. The rest of the Atlantic, you have this feature here. Again, no sign of any type of circulation, nothing of that nature. The best potential for development is back here, all the way in the northwestern Atlantic, which we'll touch on in just a moment with the rest of the forecast. But this right here is your best potential for any type of development. And of course, we have a tropical wave over the Africa. Over Africa, it could have the potential of developing, but not really standing out. And of course, the latest European, and you could also use the GFS suggesting development here. When you have a lot of these green lines, that's really a weak low pressure system. I gotta be honest, I think a lot of this is going to be overdone. And I can't rule out a tropical development because we are in the peak of the hurricane season. But right now, nothing really stands out to me. Okay. So, yes, there are some areas to watch, but nothing of immediate concern and nothing as far as a threat to the East Coast. And this is a feature we're going to touch on in just a moment that is developing over the Northwestern Atlantic. So, let's get closer to home. And closer to home, it's cloudy. We have an onshore flow, and basically that means a lot of cloudy skies, potential for an isolated shower or two. Temperatures range from the lower to mid 60s over the northern interior, mid to upper 60s in your suburbs, upper 60s to lower 70s on the immediate coast with that onshore flow. Again, there's that threat here for a pesky isolated shower or two because of that onshore flow. Nothing heavy, but you may feel a few raindrops here and there, especially along the coast. There's certainly plenty of cloudy skies. Now, we have those cloudy skies, which we can see very nicely here on the visible satellite picture. This is pretty socked in. And notice the clouds are all moving in from the Atlantic Ocean. There's our feature out here, which we'll touch on in just a moment. And there you see something approaching from the west. So this onshore flow, which when we take a look at our SKU-T, is basically transporting a maritime air mass. You can see that maritime air mass topping off at about 850 millibars or so. Let's say 825, okay? So about 825 millibars. And that maritime air mass is creating a stable environment. This is an inversion here. So what you end up with is, with all the high level moisture here at 900 millibars, cloudy skies. See how you get the temperatures and the dew points meeting here? That means that the atmosphere is saturated, and that's why we have cloudy, low-level clouds. Above those low-level clouds, hey, plenty of dry air. It's sunny when you get above that cloud deck. So if you're flying, you're going to run into plenty of sunshine while it's cloudy at the surface. So this supports a stable environment with the threat for a few isolated showers here and there, but nothing really all that impressive. And that's really going to remain in place throughout the coastal plain. As you move further inland, you'll get more breaks of sun and more clear skies. So the place to be today is in the Poconos and Catskills if you're looking for plenty of sunny skies. But what is going on to the west and to the east of us? Well, we have a low pressure system here that may try to pick up some tropical characteristics and become what we call a subtropical storm. I sometimes debate whether we're really dealing with a subtropical storm in this scenario or if we're really dealing with what's called a warm seclusion. They're different structures. The reason why I debate that is that a subtropical storm has at the lower levels, let's say from the surface up to about 850 millibars, it's driven by the evaporational release process and the cool core structure. Okay, I mean the warm core structure. Whereas in a warm seclusion, you have a ball of warm air, but the whole storm is still driven by thermodynamic properties, right? It's still a thermal gradient process in place here. So we'll see how this all plays out, but plenty of dry air. I think this is more just cold core, plain cold core, and that is about it. But again, we'll see whether or not we get a little bit of a warm core structure trying to take place here over the next 24 hours. And then we have a trough approaching from the west. And in between, we have this ridge axis. So what this sets up in this environment is that, again, you can see the storm here trying to organize. It's intensifying. Okay, so you have this trough here. You have this intensification taking place. And as this is intensifying, it's running against this trough here. So again, looking back here, here's the trough approaching. Here's a storm. Notice all this dry air, dry sinking air. So what's going on here? Well, we have a trough that is trying to develop here off the mid-Atlantic and New England coast. This divergence in diffluence is going to possibly set up the environment where we get that warm core development that could possibly develop. That's why the NHC has a 30% chance. But either way, it's all going to get shifted to cold core. So you have this divergence in diffluence and this storm developing. This leads to sinking air somewhere because you have rising air here and rising air here. You have to have sinking air here. So this leads to this ridge axis setting up here. And so what this leads to is just cloudy skies. And again, that isolated shower threat. This lifts northward. This feature down here in the subtropical jet stream, it's racing out ahead of this trough because it is a positively tilted trough. So no, we're not going to see a phase or any type of major storm, but you get this cold front that's going to be able to march through. And that is what we're going to be dealing with on tomorrow afternoon and evening. So when we take a look at 500 millibars, again, there's our little shortwave ridge. There's our storm developing. Again, I think this is more of just a cold core low than anything else, but we'll see what the NHC does. Here comes our trough, and here comes our little shortwave in the subtropical jet stream. As we move on through Saturday, notice your strongest lifting is more focused towards central New York and up towards the central portions of the Hudson River Valley and then towards New England. So yes, there is going to be showers and thunderstorms here, but I think the strongest precipitation is going to be to the north of us based on this lifting properties. And when we go down to 850 millibars during the same time period, your best focus is again towards New England. So yeah, I expect scattered showers and a few isolated thunderstorms, but I don't see this as a washout in any way, shape, or form. Just be prepared tomorrow for those passing showers. There's that shortwave in the subtropical jet stream. Notice because of the positive tilt, initially everything is kind of disjointed, right? We're not getting any phases, we're just getting a lot of features interacting with each other. And there's that ridge axis that is separating everything out. And so what you end up with is just a plain old cold front passage. And with that cold front passage, you get that enhancement of moisture lifting. So that's going to support your potential for heavy downpours. And here comes your cold air transport as well. Sunday is setting up to be absolutely beautiful. Fresh polar air mass, plenty of dry air. Look at the precipitable water values dropping here. You're talking about below a half an inch. When you're getting down into these levels, that's a lot of comfortable weather conditions. So what that looks like in the mesoscale model guidance. This is the NAM model guidance. I wouldn't use the HRR just yet. I know a lot of people like to use it out to 48 hours. I think that might be an error. You usually stay below 18 hours for that guidance, but the NAM guidance is pretty much trusting here. And again, Scattered showers, a few isolated thunderstorms, some heavier downpours tomorrow afternoon into the evening hours. So if you have outdoor plans, I would prepare for that, but not a washout in any way, shape, or form. And again, notice the scattered nature of those showers. And on Sunday, absolutely beautiful. Here's a look at that on the European guidance as well. And again, notice the strongest lifting is all focused up here. The same thing showing up as well on the NAM. The strongest lifting is focused more towards New England. So that's where I think we have the best potential. So diving into this forecast for today, cloudy, isolated shower 2. Temperatures ranging from the mid to upper 70s over the northern interior, upper 70s to lower 80s along the coast. Tonight into tomorrow morning, cloudy skies, isolated showers. Look for lows in the upper 50s to lower 60s over in your suburbs, mid to upper 50s over the interior, lower to mid 60s in your urban areas. Tomorrow, cloudy skies, isolated showers through the morning, scattered showers and a few thunderstorms in the afternoon. Those thunderstorms are going to be weak, maybe a rumble of thunder, a brief heavy downpour. Look for high temperatures ranging from the upper 60s to lower 70s over the northern interior, lower to mid 70s along the coast, mid to upper 70s in the Delaware River Valley. On Sunday, a fresh, cool polar air mass is in place with clear skies, low humidity, low temperatures in the mid to upper 40s over the northern interior, lower to mid 50s along the coast. High temperatures ranging from the mid to upper 60s over the northern interior, lower to mid 70s in the Delaware River Valley, and upper 60s to lower 70s along the coast. So absolutely beautiful for Sunday. Monday, Tuesday. Well, let's do Monday first. Monday, just high pressure and control sitting over the region. Clear, cool, comfortable conditions. Mid to upper 40s over the northern interior, lower to mid 50s along the coast. High temperatures in the upper 60s to lower 70s over the interior, mid to upper 70s along the coast. Now, for the rest of the forecast period, Tuesday on through Friday, high pressure in control. Remember what I said about the pattern shifting to more of a quiet weather pattern, will shift more of a Pacific air mass influence. This is why Tuesday through Friday is very similar. Okay. Every day is going to be like this. Low temperatures in the lower to mid 50s over the northern interior, mid to upper 50s in your suburbs, upper 50s to lower 60s on the immediate coast and in your urban areas. High temperatures will range from the mid to upper 70s over the northern interior, upper 70s to lower 80s along the coast, and lower to mid 80s in the Delaware River Valley. So basically, rinse and repeat all the way through the rest of the week. And the only threat of rainfall you have is tomorrow afternoon, evening, with maybe a half an inch of rain. That is about it. That is your forecast discussion for today. I hope you learned plenty. I hope you enjoyed it. If you do, please like, share, and subscribe. And if you're interested in this type of content every day, definitely check out the premium consulting membership, only $15 a month. Have a wonderful day, and as always, stay safe out there.